pleasure to be here talking to all of you today. I really do hope we have some time for some great conversation, and I really do look forward to questions at the end. So please do pop those in as we go. A couple quick words about myself. I've been working in technology, broadly speaking, and kind of cybersecurity and IT for about 25 years now. And really, I've spent my career in kind of two distinct phases. Phase one being a practitioner of cybersecurity and IT for 3 startups over about a 13-year period. And phase two, when I kind of transitioned to the other side of the table, working more, let's say, on the vendor and provider side, first with AWS and then with a number of other companies in kind of the cloud and cybersecurity ecosystem. And really the work that we've done here at FireTail is kind of the culmination of all of the work over that 25-year career. It's a combination of some of the technology trends that we've observed and some of the things that I've seen with customers that I've worked with over the last 12, 13 years in their own evolution as how they've transitioned into the cloud, and then how they've gone from what I kind of think of as cloud 1.0 to cloud 2.0. Cloud 1.0 really being kind of that early, let's say the early 2010s phase of cloud adoption into more of, let's say, the late 2010s and early 2020s phase of kind of refactoring and changing architectures to become more cloud native, embracing things like microservice architectures and so on. And time permitting, we'll go into a little bit of that. But I think the real reality of where we are today is what we should focus on. And that is kind of the current state of APIs in the internet that we all know, use, love, and depend on for so many things in our day-to-day lives. And the truth of the matter is, as we're all probably sort of aware, but maybe we don't explicitly think about, is that APIs are really everywhere, powering every aspect of what we do in our daily lives and powering the broader internet. Right here, you've got kind of a little bit of a basic diagram, but I want to try to make it a little bit more concrete by going through a few examples. And before we do that, I want to share some statistics that we've gathered over the last few years. And I certainly can't claim credit for all of this analysis. I'll try to cite sources, and please, just ask if there's anything that you want to know more about. But I think one thing to start off with is this is a stat actually from a couple of years ago. So I imagine the number has even increased. But 83% of all web requests are API calls. And I know that number sounds really crazy when we think about how we're using the web and how most of us in our day-to-day lives are using things like Google Docs, or we're using our email, or we're using any number of other systems. And we don't think about making API calls or making API requests as we use those systems. But really, APIs have become the building block of the modern internet. I like to tell people one way that you can kind of think about that is next time you're loading a page on your web browser, pay attention to the little status bar down at the bottom. And you'll note that there's a number of third-party sites that are being loaded in addition to what you're actually loading. So you might be reading a story, let's say on CNN or BBC News, and in the background, BBC or CNN is calling in 4 or 5 other external services to kind of create that page that you're reading. All of that is more kind of concrete real-world examples of API calls in action. And another example that I really get a lot of pleasure out of kind of explaining to people and trying to make it more relatable in our daily lives is mobile food delivery. About 7-8 months ago, I sat down with a friend of mine who works at one of these mobile food delivery companies. And we started analyzing this question that I had, which is, every time I order food via, let's say, Uber Eats, in my case being in the States, but maybe it's Just Eat if you're in the UK, or Deliveroo or Foodora, or who knows what the service is called in your part of the world, but I'm sure all of you are familiar with the kind of concept of ordering mobile food delivery via mobile. So I asked the question of my friend, how many API calls go into a single transaction? And we started kind of mapping it out, from the point where I pull out my phone and I open the app and the phone picks up my geolocation and sends that to a back-end service that then, based on my geolocation, fetches a list of restaurants and then their menus to present to me in order to show me what food is available for me to order. We kind of calculated, okay, just starting off that part of the request, we've got kind of the location and the menu presentation, we've already got about 3 to 5 API calls then. And then from the time that I start actually, selecting the dishes on my order, I submit the order along with my payment information, we get into a second wave of complexity. We've got an additional 5 to 10 API calls that are happening, but we're also bringing in multiple third parties, and we're sending very sensitive, critical data from party A to party B. So just think about the fact that, I may be submitting my order to a company like Uber or Uber Eats, and they're sending my payment credentials off to a third-party provider like Stripe or Square or somebody like that. And in addition to that, my order is now being sent to the restaurant. The delivery service is being coordinated in order to kind of figure out who's available to make that delivery, who's located in that area, who can take the request on, et cetera, et cetera. So as my friend and I were kind of mapping this out, we started kind of making a tally. We got to about 25 API calls. We said, listen, there's more coming, but this is ridiculous. There's just so many. And I think that's the way that I like everybody to think about this, in the sense of, how critical APIs are. So this is one business transaction, 25 API calls, at least 3 services and 3 vendors that we're coordinating with, very sensitive information being sent, payment credentials, my name, my profile, my home address or my delivery address, my phone number, my email address, et cetera. All of this PII, in addition to, again, my credit card details, et cetera, being sent around all over API calls. And that is, again, how the modern web works. If you are a company like one of these food delivery services, it doesn't make sense for you to build all of these third-party services. Instead, you kind of pull them in as building blocks to stitch together the flow of business transactions that you need to happen, or the flow of business logic that you need to power that transaction. And that's why I say, APIs are actually the modern kind of, call them the duct tape, or I like to call it the connective tissue of the modern internet that we all use today. So where are we? In addition to this kind of 83% of all web requests being API calls, we're actually on course to having 1 trillion programmable endpoints. Now, this is a quote that comes from an analyst who's been studying this space for a number of years. And it really kind of dovetails with that kind of cloud 1.0 to cloud 2.0 transition that I mentioned. The momentum behind containers and serverless and multi-cloud and so on is just bringing more and more APIs. And, my co-founder Riley and I, we really observed this in our own day-to-day life before we started FireTail. We were seeing this shift away from kind of legacy architectures and into more microservice architectures. And we realized that no matter what you're doing, APIs become that common thread. For every data set or every business logic or every kind of functional transaction capability that you present, it will be represented by an API sitting on a network that is available to be called and consumed. And that's really where we are. So hopefully that's all clear and gives some context as to what the modern internet looks like from an API perspective and why this is also critical. So just to kind of wrap up with a couple more stats, we are probably around 200 million APIs across the web right now. That's in terms of API services. Growing to 1.7 billion in 2030. When you think about kind of the ratio of APIs to endpoints, that's where you can kind of see that previous number kind of click into focus a little bit. One interesting observation is that private APIs are actually going to outstrip public APIs. So what does that mean? That means that, if I am a company and I present something like the FireTail API that is available for our customers to consume, behind the scenes, the FireTail API is probably communicating with 10 other APIs that make the FireTail service possible. One interesting stat that I saw recently is that over 62% of developers reported on that they rely on APIs more in 2022 than they do in 2021. Why this was particularly interesting for me is what was happening during 2021 and 2022. We were kind of in the, let's call it the later stage of coming out of the pandemic, or in the process of coming out of the pandemic. And what did we see during the pandemic? We saw massive scale digital transformation, digital enablement of business transactions that we had never seen before. And what you see is, hey, what's going hand in hand with that digital transformation? more and more API development, more and more API consumption. So what are the challenges that all of this API kind of transformation brings or poses to us? So the first one is that, when we sat down and we started analyzing all of the API data breaches that we observed or that we could find documented, we realized that traditional security really wasn't going to work. And we'll get into why in just a couple minutes, but let's talk for a second about what are some of the factors behind that. So number one is, as we see more and more APIs being launched, and we talk to developers, and you can look at a number of DevOps surveys and cloud professional surveys. And what you see is that developers are empowered to launch services directly. There are generally very few gating mechanisms that keep developers from putting new APIs into service. So what do you get as a result of that? You get something called the API sprawl. API sprawl, or sometimes you'll hear things like shadow APIs, generally refers to one of two conditions. Number one is that you've got multiple APIs serving the same function, but because there's no centralization of API capabilities, you have multiple APIs presenting either a data set or a business capability out to the world. And number two is you have APIs that things like the IT or cybersecurity team are not knowledgeable of. So they don't know that these APIs exist. That presents great opportunities for attackers because they can find APIs that are not being secured. Why? Because nobody knows about them. And of course, that actually has proven to be the case. So API attacks have grown massively over the last couple of years. I know this stat from 2021 is a little bit dated now, but we did see just a massive rise in API attacks and API data breaches in late stage 2021. Our own data shows that this trend has actually just continued. We've seen close to 1 billion records being breached or at risk of breach. And one of the interesting conclusions that was not ours, but is actually quoted attributed to somebody else, is that it's vulnerabilities in apps handling the API data that are the direct cause of those breaches. Nothing else is to blame. So even if you potentially had traditional, let's say, network security or perimeter security in place, these API breaches continue to happen. There was a good CISO survey done a little while ago around APIs, and the question was really, hey, what are some of the challenges that you see around APIs? And of course, the number one response that came back was the lack of API inventory. And just as we talked about a second ago, the whole rise of API sprawl is really kind of behind that. Perimeter security is definitely a concern. End-to-end tracing of code to API is one of the biggest things that we've heard from our customers, as well as from the CISO survey, is, hey, if we have an API that gets breached, one of the challenges we have is then mapping that API back to the application code from whence the API came, to try to understand, what was at fault in this breach. So there's a couple other things there, but those were some of the key ones that I wanted to talk about for a second. So let's dive into the data and let's talk about what we actually learned from our own analysis of API breaches over the last 10 years. So first, before we actually get into some of the stats, I did want to take a second to talk about how we examined this or how we undertook this research. First thing to state is a couple of caveats. Number one is we did our research only on publicly disclosed API breaches. If there are API breaches that were communicated to us in confidentiality, if we didn't get permission from the other party to include them in the research, we did not do that. So this is primarily based on publicly available data. So what you might think of as open source intelligence in terms of breaches and the analysis of those breaches. In a few cases, we did speak directly to the researchers who uncovered the breaches in order to get a deeper understanding of exactly what happened in those cases. But by and large, we're relying on publicly disclosed data. So of course, there are breaches that are not included if they weren't publicly disclosed. There may also be categorization of breaches into categories based on what was presented in the analysis or by the researchers. So high level number one thing. So I mentioned a minute ago that close to 1 billion records were breached or at risk of breach. And one thing that you'll immediately see here is that we're actually disclosing 577 million records breached. Those two numbers obviously don't match. The billion number includes responsible disclosures from cybersecurity researchers who reported the vulnerabilities to the companies owning the APIs, who then managed to patch or fix the vulnerability before it was exploited in the wild. So that's where you see the disconnect between those two numbers. But let's just pause for a second to appreciate that number. So 577 million records. When we go through some of these breach examples, you probably will find yourself thinking that some of them are very similar to services that you consume yourself, and it's entirely possible that your data has been included in at least one of these API breaches over the years. Second thing to understand, 13 million records per breach event. Now, I've been in cybersecurity for a while, and I can tell you that that's a very high number per breach event. And when we started to think about this and we started to kind of ask ourselves, why is that number so high? We realized it's because API breaches tend to be logical and they tend to be systematic. So what does that mean? That means if a flaw exists in an API, it doesn't disclose or it doesn't put at risk of breach certain records. It puts entire data sets or entire business functions at risk. So if you find a vulnerability in an API, you can generally extract an entire data set, or you can generally kind of manipulate the vulnerability to give you all the data sitting behind the API, or potentially trigger the API into some kind of malicious activity to your own benefit. So when you average that out, what you see is 43 unique documented breach events over the years. And what we've done secondarily is we've taken all of the information to try to break it down into a few categories to understand what are the primary risks, what are the primary attack vectors, and if we're building an API today, what are the things that we need to think about in order to make sure that we're shipping a secure API. So number one, the top two categories by a pretty wide margin for primary attack vectors are authentication and authorization. Let's take a second to talk about what that actually means. Authentication is the practice of establishing who is using this API, right? So the easiest way to think about it is, who is trying to use this? Is it Jeremy? How do I establish Jeremy's identity? That can be through some set of credentials. Often that's something like an API key or a set of, let's say 2 credentials, a key and a secret key. So like a public and private key, or something like an API key plus a certificate, etc. But it's a way of establishing the identity of the person consuming the API. We'll talk in a couple of the example cases in just a second about what are some of the common problems with authentication, but authentication tends to be the number one, or has been the number one, in terms of the number of breach events. Second, authorization. Authentication and authorization often get kind of confused because they are related concepts, but they are different things from a cybersecurity perspective. Authentication, as we just discussed, is the practice of establishing who is using the API. Authorization is the practice of establishing what is that person allowed to do. A common example I like to use here is if you think about something like a social media app. Everybody on that app probably has a profile. So I have my profile, Alan has his profile, etc. If we're standard users, I may have the permission to edit my own profile, but I only have the permission to view Alan's profile. If Alan's an administrator, he may have the right to view and edit both his profile and mine. So when we think about authorization, we're often thinking about kind of 3 things together. Who is making the request? What is the data that they're trying to access? And what are they trying to do with that data? Are they just trying to view that data? Maybe that's allowed to every user. Are they trying to edit that data? Maybe that's only allowed to the owner of the data or to administrators, but not to other users. So the authorization question is a little bit of a trickier one, and you will see that it definitely comes into play in a lot of the breach examples that we're going to talk about, and certainly in the broadest sense. Now, we not only analyze the primary attack vector, but we also analyze the number of records breached by category. And so here again, we see that authentication has actually been at fault in more than half of all data records exposed. Authorization surprisingly cuts down quite a bit on this side, but it is still one of the factors at risk in a number of things. Configuration and data exposure actually are pretty broad risks as well. Injection doesn't take a lot of the breach events, but actually is one of the ways that a lot of data was extracted in some of the cases. Overall governance is one of the things we're going to talk about in just a second, but it generally kind of is a category that captures things like network configuration, visibility, et cetera, around APIs. So you'll see a little bit of a difference between the primary attack vector and the number of events, and then the primary attack vector in the number of records breached. So some breaches are, let's say, like more impactful than others is one way that you can kind of interpret that data. But one of the most interesting things that we saw as well when we analyzed across all of these breach events is that pretty much all breach events are multi-vector. What that really means in simplest terms is more than one thing went wrong, right? So, at least two things were bad in this situation. So we also analyze the secondary root cause from all of those things, and we can see that, again, authentication and authorization are pretty big players, but there we start to see things like data exposure and governance take a little bit more prominence in the analysis. So let's talk about a couple examples, and we'll go through them in some level of detail, again, based on what we are able to learn about them. And I think one of the things that a lot of people think is that, maybe, some startups make these mistakes, maybe some, smaller companies, SMBs, mid-market companies make these mistakes. But actually, the truth of the matter is even really big brands, large companies are at risk of API breaches. So Peloton has actually been in the news just again recently. We were just chatting with somebody earlier this morning, in fact, about another set of concerns around some Peloton APIs. Going back for a second to the example that I gave of the mobile food delivery app and how many APIs and API calls are involved in that, actually every smart home device is also using APIs. There's not that much happening on the device itself. There's a lot of data transfer between the device and some cloud service, but quite a lot of that is, in fact, probably 99.9% of that is done over API communication between the device and some cloud service at the back end. So a couple of years ago, there was a disclosure of a breach event around some Peloton APIs, basically connecting the bicycles to the Peloton backend API service. So what happened here is, so first of all, the researcher tried to understand the Peloton APIs. And if you've got any kind of connected device at home, it's not actually hard to find the backend API services. You can go onto your Wi-Fi router, which does log all of the web traffic in your house, and you'll actually see your device connecting to its cloud service and the API calls that it's making. So based on that, you can actually extract the API address, so the URL of the API. You can see the format of API calls that are being sent to that backend, and then you can actually try to manipulate it if you are so inclined. So what this researcher found was that their profile ID in the API call matched their user ID that they were able to see. So then they tried saying, well, if let's say my user ID is 1 and my profile ID is 1, what happens if I change the profile ID I'm requesting to 2, to 3, to 4? So sequential numbering in API or in data records sitting behind APIs is a really, really bad practice. It makes scraping very, very easy. And that was exactly the case in the case of Peloton. The second thing that this researcher discovered was that once he was connected to the Peloton API service, subsequent calls after the initial connection were not checked for authorization. So an initial kind of attempt to connect, yes, it did need to verify the credentials of the user consuming the API service, but every follow-up call didn't get rechecked. So again, authentication and authorization, not the same thing. they need to be performed on every single API call. And that is one of the challenges around APIs. And what you actually can kind of infer from this is the requests to scrape this data actually look like normal API requests. There was nothing, let's say, in the fact of where the user was requesting from that could have been blocked by a traditional firewall or something like that. So again, vulnerabilities in the applications handling the data are the direct cause of these breaches. Next example I want to cite is Lemonade, which is an online insurance brokerage service. And here we see a really clear-cut example of kind of two things going wrong. Number one was through a set of configuration changes on the network side, the API itself, including some of the data that it served, got indexed by the Google bot. And so, of course, one good practice around APIs is to prevent any kind of bot traffic to the API. Bots are known for kind of sending weird stuff to API services. And if they get responses, they will actually do things like index that response. So this bot index the Lemonade API, the API actually starts to show up in the SERP, which is the search engine results page. The API did not require authentication or check for authorization, and it actually allowed for read-write functions. Now, this is a couple of years ago. Certainly, this has been fixed since then. But what you see is a combination of a network configuration error plus poor API design practices that led to this breach. So again, just to kind of reiterate, pretty much every API breach that we've tracked and analyzed has had multiple things go wrong with it. Then the next one I want to talk about is Starbucks. So Starbucks was a really interesting case. Thankfully, this one was actually fully a disclosure event and not an actual breach, but some really interesting findings that were published and made public. So number one is that the server configuration of the server that actually holds the API exposed routes. So what this means is I, as somebody consuming the API, could just send any random set of strings to the API, and I would get error messages that would tell me what the structure of the API looked like. So overly verbose error messaging is actually a common problem on APIs, as it is with many web server technologies. It's something that's very often done in kind of development environments in order to help developers build, let's say, services to consume APIs, but then really needs to be turned off when you get into production, and that was not the case here. But through that kind of enumeration practice, the researcher was able to discover a GraphQL endpoint that was not documented. GraphQL is a really interesting API technology that we won't really have time to get into in today's webinar, but the GraphQL endpoint allowed the effective equivalent of a select star statement that allowed for the extraction of the entire data set. So again, we see here kind of poor server configuration around, let's say, the error messaging, or maybe the server configuration between development and production. We had a non-declarative API model that allowed for really query of any data, any level of data through a GraphQL database. Just a little side note, there's a number of open source tools that you can find if you're ever playing around with GraphQL and you want to understand how easy it is to discover entire GraphQL data sets. There's any number of tools that you can find out there open source, but excessive data exposure really led to a lot of the challenges around here. So here you can see this quote: the internal API had an exposed Microsoft blah, 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 which would have allowed an attacker to exfiltrate 100 million user records, including all that PII. Then last but not least, there was a relatively recent, I think it was September of last year, breach by one of the major telcos in Australia called Optus. And here what we see is kind of a common challenge for a lot of customers, a lot of companies with their APIs. The challenge I want to talk about is basically the rate of change in cloud environments. So what you see here is, kind of again, with that shift from cloud 1.0 to cloud 2.0, getting into more modern cloud native or cloud-centric architectures, you see rapidly changing environments. And one change made by one team to a network configuration made a private API public. right? So one little network configuration change turned this API into a public service. This API had poor authentication, again, primary breach vector, again, incremental account IDs. And so you see a couple of things coming together to expose data sets. And from the person who extracted the data and posted on the dark web, no authenticate needed, all open to internet for anyone to use. So that kind of presents the problem, I think, in a very succinct, if grammatically poor way. So just a couple kind of final thoughts around this. One of the questions we often get around this is, well, okay, what about me? I work in such and such. Is this really a problem for me or for my industry? One thing you'll notice from the examples we cited, that's across many geographies, so not really geography specific. APIs really are everywhere. If you're using an internet service, chances are very, very high that APIs are heavily involved. Some industries have had, let's say, overrepresentation in the data set. And if you take a step back and you think about it, they're actually industries that make a lot of sense. Technology, software, of course, right? Why? Because software is always evolving and embracing the most modern architectures and so on. Manufacturing, automotive in particular, has showed up in pretty high numbers in the last couple of years in particular. And again, if you zoom out and you think about, well, why would that be? Number one, supply chains. Automobile manufacturing is very heavily linked between third parties. This is contract manufacturers of everything from seats to panels to embedded smart systems. And that's the number two trend. Cars are becoming connected cars. And those connected car devices are effectively IoT devices that talk over APIs to some backend service. And so we've seen a number of things around that as well. And then hospitality. So we see in the hospitality industry, you think about, let's say, airlines, travel, hotels, rental cars, et cetera. These are very connected services. A lot of the booking that happens on that side is usually happening through third-party connected services, again, connected over APIs. You might book through Kayak, Orbitz, Expedia, Booking.com, et cetera, to any number of airlines, hotel chains, et cetera. All of that kind of transaction processing is made possible by APIs. So let's talk for a few seconds about effective API security. I think one of the most interesting things that we've observed in our own work with CISOs and with our own customers is actually the things that they're looking for are really in direct response to that CISO survey. Really they're looking for the way to get visibility over their APIs. They're looking for a way to observe those APIs and assess them against good security practices. So what we see actually is, if you combine kind of these 6 goals that we mentioned here, discovery, visibility, observability, enforcement, policy, and audit, if you combine them with an adoption path that aligns to how the technology is being rolled out in your organization, and you focus first and foremost on getting visibility over your APIs through a discovery and inventory process, you automate that, you make that an ongoing process, and then your second step becomes kind of comparing the observed APIs to a policy in order to assess the risk and then prioritize which ones are the highest risk, which ones are exposing the most PII, et cetera, and you apply attack prevention first and foremost there, and you make sure that you're auditing everything. That's one of the successful implementation paths that we've seen around API security. One last comment on that is, I mentioned earlier that traditional security approaches, especially things like network security, don't really work. We really encourage companies to think about where the risk is based on the attack vector research that we've done, and also where it is based on technology. So we did an analysis of log files from AWS, and we tried to understand, if you think about what's gone wrong in these cases, what visibility do you need to have over what data in order to understand if you've either been breached or if you're at risk of breach? And you see things like authentication and authorization being so critical. Well, if you look at normal network logs, you don't get visibility over any of that. If you look at API gateways, you get things like authentication headers, but you don't get visibility into, let's say, arguments or request parameters, or into things like the response payload of what data is being sent back. So you don't actually know what data has been breached or exposed in your systems. You only get that through application logs or through logs that sit, or come from the application level. And with that, Alan, I think that is a good place for me to stop on the presentation side, and hopefully we still got some time left for some questions from the audience.
That was excellent. Thank you very much, Jeremy. So just to reiterate, for anyone who joined late and wants to ask a question, you can send me a direct message on the chat. I have a couple coming in here already. So I will start with this one from Lena. If we feel like we've covered all the security basics that you mentioned, what's next?
Yeah, great question. I mean, first of all, if you've covered all the basics, kudos to you. You're well ahead of the game, and you should be applauded for your efforts there. But really kind of two things come to mind. If you've gone, let's say, through this adoption path and you've kind of implemented attack prevention on your high risk APIs, and you've got some audit trail coming in. The two things that we've heard from customers, if you've already gone through these steps, number one, try to establish end-to-end visibility. So getting that attack prevention in production environments is awesome, but what you should also be trying to do is get rid of all vulnerabilities in your APIs over time. One of the ways you do that is you kind of trace back end to end to the code where the API is defined, and you work with the application teams and the owners there. Second thing is correlation. One of the things that a lot of organizations struggle with is kind of a disconnected set of data around all of their cybersecurity signals. And so one of the things we've heard from a lot of organizations is, hey, my APIs are actually just a piece of my overall cloud environment. What I'd like to do is correlate my APIs to my overall cloud stack and look at that as part of my cloud application environment in order to either assess risk or to assign who's responsible for responding. So end to end, correlate with other stuff in your environment if you're already that far ahead of the game.
Excellent, excellent. And I have a couple of questions here that are along the same theme, so maybe you can handle them all together. Where did you get all of the data from? How current is the data, and what has happened since the report came out?
Yeah, great question. So we got all the data from a lot of research. So we monitor a number of cybersecurity sites. We are also directly in touch with a few people who do research in the API security area, and they report some of that data back. By the way, we actually track all of it. On the footer of our website, you'll see a link to something called the API Data Breach Tracker. So we have all of the data that we are able to share is posted there. You can see the source material for where we got all of these breach events there. You're welcome to have at that yourself or peruse that on your own. But primarily we got it through, kind of open source across the web. Second, we released this report initially, I want to say in kind of April of this year, so a couple months back. So that's about how current it is. There definitely have been breach events since then. A couple again on the automotive side around connected cars, a pretty major one around power usage meters recently. One just a couple of weeks ago that just leaked 50 million user records on a media site in Asia. So, the breaches continue to happen. There have been some pretty large scale, big ones from, again, big name companies where, you can't really say like it's just small companies having these problems.
Great. That was very good. Thanks, Jeremy. I have one here that we were bound to get. So what impact do you think AI will have on APIs?
Yeah, this is certainly one that I get a lot when talking to anybody nowadays, because of course AI is the hot thing in the tech landscape. I mean, look, there's both good and bad in AI, specifically from the API security standpoint. I won't get into other areas around AI, but just specifically thinking about API security. The good is APIs, like a lot of things, create a lot of data. They create log files, they create transactions, they create records of what is being requested, who's doing it, etc. There are things that we can do with AI tools to kind of analyze API behavior, usage behavior patterns, etc. We can look for anomalies, we can look for specific patterns in the research, and we can do that at a scale and at a speed that is actually beyond human capacity. So there's some really good, obvious scenarios where we can benefit from AI. The bad side is, of course, that hackers have AI too. And so when we think about some of these, particularly some of these secondary breach vectors around things like excessive data exposure or injection, AI can be used to kind of test APIs or to kind of prod at APIs repeatedly. Like, oh, I could extract this record. Well, let me create every version of that record ID that I could think of using some AI tool and try to request those records as well. So I do think as we go forward, we will see some APIs breached with the help of AI, unfortunately. And it's just, our job to stay on top of that as best we can and to, use it for the good side of things to improve our product and services as best we can.
Great, thanks a million. Another question in here. What are all the actions and events that should be logged by the application?
Yeah, that's a great question. We have an opinionated view on this, though, again, from our own observations, knowing that things happen at the application layer, we really make sure that we want to try to capture as much as possible. So we do things like capture, source IP address, user agent, timestamp. We do an IP lookup for organization and geography. And we try to kind of establish personas based on that from the caller standpoint. But of course, we know IP addresses are both fungible and ephemeral. And so, you can't rely on IP addresses on their own. You should track them to be sure. So all of that from the caller standpoint, we should also track, let's say, like the performance time, the response time of our APIs, as well as the data going out. You may or may not need to scrub the PII from the requests and the responses, depending on your own, let's say, GDPR or HIPAA or whatever regulatory compliance requirements you might have. We do that for our own service and for our customers. We do scrub PII out. But we do particularly find that one of the most important things is to log the data that has been returned. Why? Because for that, knock on wood, hopefully it doesn't happen, but for that time when you do get breached, we just saw I think a new regulation come into effect, or at least get proposed just yesterday or the day before, that all firms will need to disclose their cybersecurity breaches within 4 days. And along with disclosing the breach, you need to be able to understand the impact of the breach. Who was affected? Was it just Jeremy and Alan, or was it everybody in our data set? And we're going to have to respond based on that. So we really think, you need to log pretty much everything you see on this page, and maybe even a little bit more. We track everything here plus a bit.
Gotcha. So look, we're just at the bell. I'm going to squeeze one more question in. So quick question for Jeremy. Do you recommend deploying a multi-API security vendor approach similar to traditional WAFs? This would assume that not every API is the same.
Great question. There's a lot that goes into it, so it's not a quick answer. But look, I really recommend for every organization to kind of take the approach that makes the most sense for your organization. If you think about kind of that adoption maturity path, the first two steps here are really around kind of identifying and assessing the risk to your organization. So it's about finding your APIs, understanding what kind of APIs they are, how well built they are, what data they're processing, et cetera. Based on that, you might want to take a multi-type or a multimodal approach to API security, because you realize that you've got these REST APIs over here and these GraphQL APIs over there, or you've got these public APIs here and those private APIs there. That is a decision that you probably need to make. But what I would say is, like, the most important thing is to make an informed decision based on the risk and really based on the tolerance. Everything we do in cybersecurity is really informed by the risk to the organization and the risk of breach or reputational damage or whatever the risk that is important to you and your company is. So I always say, start with discovery and inventory, go to assessment next, and then based on the risk you discover from that assessment, then make an informed view on how you really want to try to tackle the problem.
Excellent. Great. Thanks a million, Jeremy. So look, I think we'll wrap things up there. If you could just push the slides on to the final, I'll show people where they can access. So on the left here, guys, you can get the full State of API Security report that Jeremy has just shared insights from. And also to let you know, this is a series of webinars we'll be doing, one a month. We're going to aim for the final Thursday of each month. So if you'd like to register in advance for our next one, whereby we will look at the most recent update to the OWASP API Security Top 10, we'd really love you to join us. So just from me, from Jeremy, from the whole team here at FireTail, I just want to thank you all for joining us today. We will be sharing the recording of this. So I know there was a couple of attendees that might have come in late. You'll be able to access the full presentation once we publish it on our website. So thanks again, and look forward to seeing you on future webinars. Take care.